Okay.
Yeah, Abdulaziz, I don't know.
Okay. Thank you, Sadiq. Hello, everyone, and Assalamu alaikum. Thank you so much for joining the call today. I really appreciate your time. Eid Mubarak to you all. I hope all of you had a great holiday. Today, we are covering one of the very important topics with very well-known speakers. We are having Duncan and Frank and Cormac, one of the chief technologists team who's going today to discover a session about the vSphere, Kubernetes, and the vSAN. I truly appreciate your time today, and I will leave it to Duncan and the rest of the team to start off this session. So I will leave it to you, Frank.
Yeah, thank you, Abdulaziz. Let me share my my screen. Hi, everyone. My name is Frank Denneman. I'm a chief technologist in the cloud platform business unit, together with Duncan and Cormac. We work at the office of the CTO for this business unit. So this business unit is responsible for products like vSphere and vSAN and all the core elements. So I'm kicking off this session or this roadshow, and during the roadshow, we would like to have interactions with the all the attendees. So please use the chat function to ask questions. We will try to answer them while we are presenting. If the presenter is not able to answer, the other two presenters will try to answer the question. Or what we can do after each presentation, we can have a short Q&A session afterwards where we basically discuss those questions. So please feel free to enter your question in the chat. So the agenda for my presentation is all about the arrival of containers in the data center. And once you're created this self-service platform, how can you ensure that the developers using the platform safely consume the resources you make available, and how can you help them achieve the best performance in this setup? So let's start off by looking at containers and how they arrive at your data center. So when we are talking to our customers, we have discovered over the last few years that most customers are slowly replacing the commercial off-the-shelf software. Basically, that's software that you can install by downloading an executable or still using a DVD. And they are trying to replace it, or they're replacing it with self-made applications, self-developed applications. And one of the consultancy firms or analyst firms, IDC, made a prediction, and they said over the next 5 years, expect 500 million cloud-native applications to appear in the enterprise data center. Now, that seems like a really giant number, like a really large number. And if you look at the newer ways of developing applications and the newer applications by itself, so think about containerized workloads or machine learning workloads, that number is not necessarily a crazy number anymore. So let's focus on ML for a bit. So with machine learning, you're using a lot of data, and you're trying to use that data in a model to get a prediction. And in order to get that data into that accelerator, like a GPU, for example, you need to transform it and extract it and do some work on it. And typically you deploy a pipeline, and that pipeline is rather like 20 or 30 steps, and each of those steps is typically a containerized workloads. So for one ML model, you're seeing 20 to 30 containers appear in your data center. So if you think about the number of enterprise data centers in the world and think about the newer ways of developing applications, that number of 500 million doesn't seem that weird anymore. Now, maybe you say, look, I'm not focusing on machine learning right now, and we actually don't have developers. So will I see a cloud native application or a containerized applications? Now, interestingly enough, we see that a lot of software vendors are looking into using the container as a distribution method of deploying the applications. And a great example is SAP software, which provides their newer functions as containers to their customers. So it doesn't mean if you don't have developers that you don't see containers. Chances are that the software that you're using will appear as a container down the line. Now let's take a closer look at a modern application architecture. And one of the things what you typically notice, if we look at the media, and if we looked at popular Twitter accounts and all that stuff, everybody talks about containers and Kubernetes, and that's about it. The world revolves around Kubernetes, the world revolves around containers. So you might get this impression that that is the only thing that happens in the data center of the future. Well, we have a different opinion about that because we typically talk to our customers deploying a lot of the existing workloads that run the world right now. And so if you take that example from a containerized application, and maybe we can use like an online bank app, like a bank wants to deploy a new service, a online banking service. So they are going to use a couple of developers and write this application that provides that online banking service. Well, typically those developers want to create it in a containerized application, and it makes sense, right? And so they create this containerized application, but that thing cannot run on thin air. You need to run it somewhere. And one of the things what we typically see with modern applications is that they are of distributed nature, meaning that there is not a single one, but there are multiples in order to provide scalability, in order to provide availability and all those things. So you need to have a platform that can orchestrate the running and the availability and the accessibility of that application. And that is where Kubernetes come into play. And if we zoom in a little bit into Kubernetes, what you notice is that there are actually two types of nodes. There is the Kubernetes control plane nodes, and there are the worker nodes. And the worker nodes here depicted in blue are the actual nodes that run those containerized applications. The Kubernetes control plane is the platform that makes sure that the container is started on a node, runs on a node, gets the resources, and if something happens to that node, will restart it somewhere else, basically the availability. And of course, role-based access and other security and network functionality. Now, this is typically the thing that you see in the media. This is it. New containerized application, Kubernetes, you're done. Well, not exactly, because let's use that online banking app again. You have that service up and running, but who can connect to that service? You need to verify if that person who connects to that service actually has a bank account. So you need to go to the customer database and you need to go to the accounting database. And typically those run inside virtual machines. That means that a containerized application needs to connect to those traditional application and databases on the VMware platform. And so what you see here is actually a world of two different personas. There's the developer and there's the IT ops teams responsible for the data center and all the platforms active in it. And so the developer wants to understand that, hey, I want to run this online bank app, but I need to have this connectivity to those applications So how do I deploy this app that I can connect to those applications and databases? And how do I operate it on day two? Meaning that if something happens to that traditional application, to that accounting service, or to that database, how will my application, my containerized application, respond to that? And of course, like lifecycle management, like updating, and all those things. And so the question for the developer becomes, what type of tools can I use in order to see my own environment, but also have a better understanding of the environment that provides the services that I so desperately need in order to run my application. Now, from an IT ops perspective, now they're seeing a new platform that connects to their traditional application and databases. So how do you provide availability to this entire platform? How do you ensure security? Not that that containerized application becomes this open area where everybody can basically connect inside the data center, making it very unsecure. And also, how do you deliver quality of service? You want to run your databases and your traditional applications very well, but also this new application needs to get the resources it deserves, especially when it's a customer-facing application. And also, how do you control the cost of the infrastructure? You have a developer, they want to deploy a lot of applications, they want to have the best performance, they want to have the best resources. Well, that typically costs money. How can you provide an environment that is smart, efficient, and cost-effective? Now, these questions are very interesting, and we've been thinking about these questions for actually quite a long time, because Kubernetes was released in 2015, and we were actually quite early to the party, because in 2017, we released Project Hatchway, and that provided a persistent storage volume to containerized workloads. In 2018, we released NSXT 2.x that provides application or container networking policies and container to container networking and all these networking services that are so needed by these cloud native applications. In 2018, we acquired Heptio, and one of the key elements of Heptio is that 2 of the 3 original founders of Kubernetes, they went away, or basically they quit Google to start Heptio, and we acquired Heptio, and that means that we acquired a lot of the brain share and the brain trust of the Kubernetes platform by acquiring Heptio. Now, in 2019, we announced vSphere with Kubernetes at VMworld in 2019, and one of the things that we were talking about was TKGS, Tanzu Kubernetes Grid Services, and native vSphere pods. So when we look at the differences with vSphere 7 with Tanzu, you can do 2 things. You can run a containerized application as a native construct within the ESXi host, similar to what a VM is, and you can create this service that allows developers to spin up their own Kubernetes clusters inside virtual machines. So now this vSphere 7 environment becomes a platform for developers and the IT ops teams to create this modern application architecture. Now, during the roadshow, we are primarily focusing on TKGS, on the Tanzu Kubernetes clusters inside virtual machines. But let's take a closer look at the vSphere pod, the native construct of VMware and Kubernetes. So when we look at a container is actually nothing more than a couple of processes. Typically, a container is run in a Linux environment. Yes, you can run a container in a Microsoft environment, but what we typically see is that the majority of customers are using a Linux operating system. So a container is a collection of Linux processes. Now, in order to run a container, you need to have a Linux OS. ESXi is not a Linux OS. So we need to make something that allows us to run a Linux OS, provide hardware resources, and be able to schedule it. And that sounds really familiar because what we are using is a virtual machine. We're using a lightweight virtual machine that is using para-virtualized devices and our own Linux OS, Photon OS. So we can create this very lightweight virtual machine with just a few megabytes of actual footprint. And inside that virtual machine with a Photon OS, we actually run our own container runtime. And this allows us to interact with that virtual machine in order to spin up containers. And that's basically what a vSphere pod is. But most of the presentation is looking at TKGS, the ability to spin up a Kubernetes cluster inside virtual machines. So that allows us to create this self-service platform for developers. They can use their own tools in order to spin up a Kubernetes cluster without interacting with the ops team. Now, the beauty of this idea is that they can spin up the environment, but the IT ops team can now see everything that happens. So the infrastructure is still centrally managed by the operations teams. So how do you do that? Now, that's something that I'm going to discuss in the next part. I'm going to touch on some of the elements quite briefly, but Cormac will deliver a more in-depth view of how to set this platform up. So when you go into vSphere 7, into vCenter 7, and you're looking for Tanzu, there is nothing there that has the word Tanzu in it. In order to create this platform, you need to enable what's called workload management. Now, workload management can be used with NSXT and with vCenter server network, and that is the vSphere distributed switch with a virtualized load balancer. We have HA proxy and we have a new NSX load balancer. This is something that Cormac will touch upon as well. Now, if you go through all these steps, and Cormac will talk about it, but he also has made this incredibly well-written blog series about how to set up workload management. And if you follow all those steps, you actually arrive at the right side of the screen when you have your vSphere cluster. In my case, that cluster is called NX. And now what I see beneath my 3 hosts is I see a resource pool called namespaces. And that namespaces resource pool is created by workload management. And within that namespaces, there are 3 virtual machines, which is called the supervisor control plane VM 1, 2, and 3. That is the control plane of the Kubernetes environment of the vSphere cluster. And if we combine vSphere with Kubernetes, that's what we like to call the supervisor cluster. Now here you can see I deployed HA proxy as a load balancer service. So that's the beginning part of your environment. And so from this point on, the vSphere cluster exposes a Kubernetes API endpoint. And that allows the developer to use their own tools in order to do and engage or do things and engage with the vSphere cluster. Now, that might be a little bit frightening to some, because now you're pretty much handing over the keys to somebody else who might not have the same infrastructure knowledge that you have. So in order to make it more safe, and what we like to call apply a guardrail, is we introduced a new functionality called namespaces. And so that namespaces is created by the ops team, and that defines the quality of service of the cluster that is provided to the developer. So let's go into that a little bit more. So once you set up workload management, there's this new option called create namespaces. Using the same example as before, I want to create a namespace for the developers that are going to deploy the online bank app. So I select the cluster, I give it a name, online bank app, I select the network for the machines to be deployed in, and I can create a description. And when I click on create we see this screen. And this screen is the summary page of the online bank app namespace. Now you can see on at the left side of the screen that you have namespaces, and there's this new icon with online bank app. And if you click on that, you will see the summary page. And what you see here is the status, like it's running, it's active, what is the location, what type of permissions, storage, the capacity and usage, and how many Tanzu Kubernetes clusters are deployed within this namespace. Now, what you see here is that I haven't configured the permissions and storage yet. So let's do that. So if I go to permissions, I can select the identity source. In my case, this was vSphere local. I select the group online bank app developers, and I say they can edit. Now I need to provide a storage policy for the containers and for the TKG clusters. And so I selected the vSAN default storage policy. And once I click on OK, I'm pretty much done. But there is this extra option, and that is the resource limit. That is the physical limitation of resources available to this environment. So in this case, I provided a resource limit of 50 gigahertz and a memory limit of 64 gigabytes. That means that the developer can deploy virtual machines in it, but they cannot consume more than those 50 gigahertz and those 64 gigabytes. When you click on OK, you can actually see that in the summary page of the namespace. So in one easy view, you can now see the entire quality of service provided to this application. So in a sense, you can use namespaces to actually start to manage applications at the cluster level, because you are starting to group those virtual machines and those TKG clusters together that will provide those application service. So from this point on, the developer can use their own tools. Say, I want to have a TKG cluster and I want to deploy it in the online bank app namespace. So this is more or less similar experience for the developer as going to a global cloud provider like in Azure or like in Amazon. But instead of going to a website and clicking things and selecting which size of Kubernetes cluster they're using, they can use their own tools and connect to the on-prem data center which you manage. So it's a far more integrated experience. Instead of going to a website, they're just using the command line interface. Much better. And so the next step is create this consumption strategy. How can you help the developers to consume the platform in the most efficient and the most effective way? So one of the things that the developer does in order to deploy a Kubernetes cluster is they're using this deployment YAML file. And within that YAML file, they're specifying all types of configuration items. And one of the things that they configure, what they need to configure, is the size of those TKG nodes. Like I said before, you have this control plane nodes and you have these worker nodes. And in this case, the developer is creating a Kubernetes cluster with a single control plane node and 2 worker nodes. And now what they need to do is they need to specify a particular virtual machine class. That is the size and particular services for these virtual machine. So in total, by default, there are 16 virtual machine classes. That's something you see on the right side of your screen. You see some best effort and you see some guaranteed types with a definition behind it. So let's take a closer look. And what you see is that if you look at a best effort virtual machine class, there is no CPU reservation and no memory reservation, meaning that they can get the resources if there's no contention. But if there's contention, then they will get the resources based on their activity and based on their share value, and on that is typically defined by the size. Now, this is typically a very nice solution for testing environments, for environments that don't need to have consistent performance and need to have those physical resources available to them all the time. Now, production, something different. That's where you want to have consistent performance. That's why you want to have physical resources allocated to those virtual machines all the time. And that's why you want to use guaranteed, because a guaranteed class has a CPU reservation that's equal to the CPU configuration and a memory configuration equal to the memory configuration. So that configuration is defined by that suffix like large. And so a guaranteed large is it will deploy a virtual machine with 4 vCPUs and 16 gigs of memory with a 4 vCPU reservation and a 16 gigabyte memory reservation. But maybe you don't want to use the default virtual machine classes because maybe it doesn't fit your environment. And as you can see, maybe you don't want your developer to deploy an 8 extra large control plane node with 32 vCPUs and 120 gigs of memory all reserved. So what we've introduced in vSphere 7 update 2a is the Tanzu VM service. And that allows you to do a couple of things. And one of the things is to actually define and customize virtual machine classes. Now, one of the recommendations that we have is leave the default classes just as they are, but create additional virtual machine classes and only provide those classes to a particular namespace. And so what you see here on the left is you have the virtual machine service, and it shows how many virtual machine classes there are, 16, which is the default. I also have 3 virtual machine running with those virtual machine classes. So that's the reason why I don't want to adjust the default. But what I can do is I can click on create virtual machine classes. And that's the screen, what you see here on the right. What I created was a burstable small virtual machine class with 2 vCPUs, 4 gigs of memory. And now I selected a percentage for the resource reservation that is lower than 100. So this is pretty much similar to the burstable QoS class of Kubernetes itself. So you can provide a particular number of resources to be there and provide it to those virtual machines all the time. But when they spike, they need to use their share value. And so if it's there, they can use it. If there's contention, they might have lose it. But that's the nature of a burstable workload. And so once you set it up, you can actually select the virtual machine classes that you want, and you can apply them to a particular namespace. Now, the developer can actually use the command line interface in order to query the virtual machine classes that are available within the namespace itself. And so they can use that in order to define their virtual machine configuration for the TKGS environment. And one of the key things what you can do, because you have the insight of the infrastructure, you have the knowledge of the environment, so you know exactly what is a good fit for your environment and which virtual machine sizes are not really a good fit. And so if we look into NUMA, non-uniform memory architecture, the ability to have consistent memory performance because you have localized memory, we have pretty much 3 different virtual machine types. We have what's called a narrow virtual machine type that can fit inside a NUMA node, so a collection of CPUs and memory. And we have a wide virtual machine that needs to span multiple NUMA nodes within a server. That's the third option, which is called a high density wide VM that can actually use, or basically spanning all the cores in the system, and requires the kernel to actually use hyper threads as well, because there are so many vCPUs assigned to this virtual machine. So what you can do is you can create these classes of narrow virtual machine, and because they're narrow means they're sticking inside a single NUMA node, and that means that they're actually experiencing a unified memory access, meaning that all the memory access that they do will have the same bandwidth, will have the same consistent latency. That's what we typically call a UMA system. So now you can create UMA virtual machine classes. And this is what you can say to your developers. If you want to have a low latency, consistent performing application with not the need for vCPUs, select a UMA virtual machine class, because that's where you get the best performance for your application. But if you have a incredibly large container that needs to have a lot of vCPUs and is NUMA aware, use the NUMA classes. And so you define your NUMA small, medium, large, and extra large. This is just an example. You can do whatever you want, but this is seen as quite helpful by a lot of our customers. And so once you're talking to your developers, you can actually have a dialogue, or maybe you can create this presentation to your developers and saying, okay, when you size your Kubernetes cluster, think about how many operations you expect, because that actually defines the size of your control plane node. If you're running a Kubernetes cluster for a production application, you might want to use a guaranteed virtual machine class. If you do an interactive test, maybe you can do a best effort one, or if you're not that confident, maybe you can use a burstable if you created burstable apps. Now, one of the things is availability. So a lot of developers trust Kubernetes to deploy, to provide availability, but actually vSphere HA might be quicker to respond to node failure than Kubernetes can. So if we dig into that a little bit more deeper, and if we look at the Kubernetes layout, you run your containers on worker nodes, and maybe the developer does this by deploying it via a command line, or you use a CI/CD pipeline. But in order to do so, you need to connect to the API server that runs inside a control plane node, and that API server accepts that instruction, typically by a YAML file, and stores it in the etcd server. And after it is stored, the Kubernetes creates this event, and there are all these controllers and operators, such as schedulers, and they look for those events. And once they see that event, they're going to do their own thing that is required in order to make it successful. Now, that means that etcd, the database, is really important. Now, an etcd is a key value store, which is quorum based, meaning that you need to have the majority of nodes still available in order to let it run. So if you have 3 control plane nodes, you can actually tolerate a failure of 1 control plane node, because there are still 2 etcd databases up and running. Now they are they synchronize, so they know exactly what state everything is. But maybe you're risk averse, and maybe you want to tolerate more than 1 control plane node. So developers are then eager to deploy 5 control plane nodes in order to tolerate 2 control plane node failures. For the really risk averse, you can actually deploy 7 control plane nodes in order to tolerate 3 control plane node failures. Now, this may sound like a little bit of overkill, but if you look at the timeline that Kubernetes uses, if there's a failure event, you will notice that it actually takes Kubernetes up to more than 350 seconds in order to restart a host or do something in order to get everything up and running again, or making sure that the desired state is satisfied. Now, HA typically takes 30 seconds to respond, and then does it magic really fast. So maybe what you can explain to your developers is that, hey, deploy a 3 node control plane, so in order to get your etcd resiliency, but trust vSphere HA in order to restart a virtual machine if one of the nodes fail, or one of the ESX hosts fails, because typically HA will restart that host faster than Kubernetes will respond to that failure. Right? So there's this hybrid notion where things become better together. And so from a worker node perspective, the size of the worker node is pretty much based on what type of application are you running? Are you running one application? Are you running more applications? What is the requirements? And that defines the size of the worker node. And one other thing is that typically you deploy multiple replicas of that application, either for availability or scalability performance. And so the number of worker nodes is also defined by the application requirements. Now, what you need to understand is that Kubernetes is a Kubernetes worker node is actually a soft fault domain. The control plane nodes want to deploy a replica, one replica per node. So if you have 3 worker nodes and you say, I want to deploy this application with 3 replicas, every worker node will get 1 replica. But if the developer saying, I want to have 6 replicas, but still have 3 worker nodes, Kubernetes needs to deploy those additional 3 somewhere. And what Kubernetes is going to do is going to deploy 2 replicas per worker node. So that's what we like to call or refer to as a soft fault domain. Now, again, for test or production, use the appropriate virtual machine class. So one of the things that I want to address as last is open up a conversation with your developers. You don't have to be a part of the deployment phase, but if you have communication with your developers and explain how the vSphere platform works, it helps them to understand that actually vSphere is one of the better platforms to deploy your cloud native applications. We have a lot of brilliant services that you've been using for the last 20 years. Think about HA, think about DRS, all those nice things. And it can actually help Kubernetes. And so one of the questions that you need to ask is, how busy will your environment be? And once you know that, you can actually start to think about, do I need to assign or deploy a separate environment for my developers to run Kubernetes in? Because you're still using vCenter and you don't want to have 100 developers using the same vCenter that you're using, because maybe you're lost in the line in order to do things, right? And so you want to do the same approach as what you do with virtual desktops, separate vCenter and create their own control plane. Now, one of the key elements, and I think a lot of you are familiar with the concepts of HA, use that to open up the dialogue with the developers. Explain them how vSphere HA works, how good it is, how it can be very helpful to reduce the complexity of their own Kubernetes environment. And with that, I'm at the end of my session. After my session, Cormac will take over and present part number 2. And after Cormac is done, Duncan will finish the roadshow with his session. Thank you for your time. Any questions, guys?
No, there was no questions in the chat or the Q&A, Frank. So
nice.
I think we can
probably
ask
a question? Hello?
Yeah, of course.
You explained about the Kubernetes. Is there any option for using a pods? Does it support a portainer? Because since portainer is also getting more and more in the environment. So is it supported in the Tanzu?
Sorry, Mohammed, I didn't get
instead
the first
pods,
part of.
Yeah, instead of pods, does it support portainer?
Well, a pod is a collection or construct that is that holds the container itself. Yeah. So we need to run that container, which is actually just a few Linux processes. We need to run it somewhere. And so if we're talking about a vSphere pod, that allows us to run that container. And so one of the things, what we do is we create this vSphere pod, but actually it's kind of transparent. So if you deploy a vSphere pod in vCenter, you will see that pod and its containers show in the UI, and you can do all the things that you can do or not all, a lot of things what you can do to VMs, you can do to containers. Now, when we're talking about portainers, is that what you mean, the open source container environment?
Yeah.
Okay, I'm not sure. I don't think so. Maybe Cormac has an answer, but at this point in time, we're focusing on our own development of our own products. So Kubernetes inside of TKG, which is a upstream compliant Kubernetes deployment, and the container inside the vSphere pod. And the vSphere pod is something that is managed and owned by VMware itself. Cormac, are you familiar with Portainus?
No, I haven't come across it before, but it looks like it's just another application, Frank. You know, it's like a UI. So I don't suppose there's anything that's, you know, we would actually care about. It would just be another application that we would stand up inside or Kubernetes. So, yeah.
Yeah, well, I don't think.
You.
Yeah, but if it's integrated in vCenter, I'm not so sure.
Yeah, no, there wouldn't be any integration. No, it would just be a standalone. It would be like any other application that you would deploy in Kubernetes. So yeah, we wouldn't really care what the application is.
Yeah, I guess the question is, Mohammed, if there's a particular use case where you would feel this would be interesting, feel free to just send an email to Frank or to Cormac so they can take it back to the engineering team and to the PM team and see, you know, what the synergy is and what the possibilities are.
Okay, sure, yeah.
Because as you can imagine, and we've had this during every single event, there's always a new tool, a new solution that pops up. There's probably, you know, over, 10,000 of different tools right now to do anything in the Kubernetes space. So it's difficult to integrate with everything.
Yeah, understand.
Okay, I may as well share my screen. Hopefully you can all see this. So hello, everyone. My name is Cormac Hogan. I work with Frank and Duncan. I think Frank has done the introductions already, so I won't spend too much time on that. So I'm going to build on what Frank has shared with us so far. Frank has sort of set the groundwork for us. I'm going to look at this from a practical point of view. So we've talked about vSphere with Tanzu. We've talked about TKG clusters, running Kubernetes, running apps in Kubernetes. So that's what I'm going to focus on in this particular part of the presentation. Again, we have the chat open and the Q&A. So if there's anything that you have a question about during this presentation, please feel free to pop in a question and we'll take care of it. So you may be a little bit confused by all the different Tanzu terminology. So I'm going to start off by just setting the stage and telling you what the different Tanzus are and which one we're going to actually be talking about in this particular session. When we first released vSphere with Tanzu, there was a lot of requirements about it. In particular, we only supported it initially with VCF, VMware Cloud Foundation. So I'm going to talk about what those initial requirements are and how we're looking to relax those going forward. And then we'll get into a deployment. So I'll go through the deployment of what we're calling the HA proxy, which provides a load balancing service. And then we'll get into the deployment of vSphere with Tanzu in earnest. Now, the thing is, you won't see vSphere with Tanzu in the UI anywhere. It is referred to as workload management. So we'll talk about how to get that deployed. And last but not least, we'll look at the final practical example, which is what the major use case of vSphere with Tanzu is, and it is the ability to stand up different, basically create different isolated clusters that Kubernetes clusters that your developers or your teams of developers can work in isolation. And I'll close with one last thing, which is a description of a new feature that we announced just earlier this year, which is a vSAN data persistence platform, which is very interesting from a Kubernetes and modern application perspective. So these are the different Tanzus that we have available now at VMware. The first one, TKGI, that used to be known, excuse me, that used to be known as Enterprise PKS, and even before that, it was the Pivotal Container Service. So that's now been rebranded as the Tanzu Kubernetes Grid Integrated Edition. I'm not going to be talking about that particular edition in this presentation. There is another Tanzu, the Tanzu Multi-Cloud or TKGM. This is the version of TKG which can be deployed on multiple clouds, private cloud or public cloud. And so you could deploy it on vSphere, you could deploy it on, I think, AWS, maybe even Google Cloud. So there's a bunch of different platforms or clouds that you can deploy this onto. So this is not the edition that I'm talking about in this session either. The final one is the TKGS, or the Tanzu Kubernetes Grid Service, which is available with vSphere with Tanzu. And so once we have stood up vSphere with Tanzu, we will have the ability in the individual namespaces that Frank described to actually build individual Kubernetes clusters, which are VMware engineered, VMware branded, but very much upstream Kubernetes. And so it is a service within vSphere with Tanzu that deploys these TKG Tanzu Kubernetes Grid clusters. So that's what I will be talking about when we're talking about the Tanzu portfolio. So again, just building on what Frank shared with us in the initial session. So we have our vSphere environment. And so what we do is we enable vSphere with Tanzu. And as I said, it doesn't appear in the UI like that. It's referred to as workload management. And what we do there is we deploy out a control plane, what we call the supervisor cluster. And that is a set of 3 virtual machines, which gives us an interface into actually being able to create other objects and other components on top of vSphere with Tanzu. And Frank talked about this namespace concept, basically a way of allocating a set of resources to different developers, different teams of developers. And then once they have that set of resources as a namespace, they can go ahead and they can do various configurations on that namespace around limits and deploying applications and so on inside in that namespace. And we will get into the different configurations later on. Frank has covered quite a bit of them already. So once we have the namespace created and we hand it off to the developer, what are the kind of things that they can build inside in this namespace? Again, we talked about the concept of the pod VMs, which is they're, for want of a better description, container in VMs. If you're familiar with the vSphere integrated container product that we already have, this is very similar to that. And so you get the agility of working with containers, but you get the security and the isolation of a virtual machine. So that's one such thing you could do. With the release of 7.0 update 2A, we also have the ability to build virtual machines in that namespace. And when I say we have the ability to build these, what we're saying is that the developers, through simple YAML manifest files, can actually build out these objects in their namespace. So they can create vSphere pods, they can create these virtual machines, but really what we see mostly is the ability to build these guest clusters, these upstream VMware engineered, VMware supported Kubernetes editions. And it's not necessarily just one, but you could have, a whole set of different clusters inside in the same namespace, all being operated by individual developers or indeed teams of developers. So that's essentially what we see. Now, as I said, when we first released vSphere with Tanzu, there was quite a lot of restrictions. And the first edition that came out early last year, it actually had a requirement that you had to have VMware Cloud Foundation. And so there was a reason behind that, because Kubernetes has, it requires a lot of resources. It requires compute, storage, networking, the ability to be able to manage and monitor it. And the best way to be able to provide all of that from an infrastructure perspective was through VCF. And so if you're not familiar with VCF, it's basically our easy button for standing up a software-defined data center that has your virtualized compute, your virtualized storage, your virtualized networking. So once you have all of that infrastructure in place as an SDDC, there are a bunch of services that once you enable vSphere with Tanzu, we make available to the developers. So we talked about the pod VM service. These are the vSphere pods. The containers are run as VMs. There's networking services here. There's a load balancer service required. The load balancer network is essentially how you would interface to Kubernetes and how you would interface to your applications. And so you need a load balancer mechanism to provide that. And we were using NSXT, or we continue to use NSXT there for that service. But there's another service as well called the overlay. It's like tunneling service so that pods can communicate to each other securely as well, even when they're on different nodes. in the cluster. So again, NSXT was providing that tunneling service for the pod-to-pod communication. We have a registry service provided by the Harbor product. It's an open source product. It's a secure image registry. So rather than having your developers go out to the internet to some unknown registry to pull in images, you can store all of your secure images locally. And last but not least, there is certainly a need to do persistent storage for Kubernetes applications as well. In Kubernetes, they're referred to as persistent volumes. And what we have is our own driver that allows us to consume vSphere storage on behalf of Kubernetes objects to provide persistent storage there as well. So we had all of those services, but I suppose the one that's quite interesting for us more recently is the VM service. And this is this ability to actually build virtual machines through simple YAML manifests that Frank described to us. Having said all of that, the most popular use case is still the ability that once you have a namespace created for your developer is to build them an upstream Kubernetes, or for them to build them for themselves an upstream Kubernetes provided by TKG, Tanzu. And so, yeah, you have all of these different things that you can build inside in the namespace. And yeah, you know, the developer would, as long as they have their namespace, they can absolutely go ahead. They can build the TKG clusters, but you could also go ahead and build pod VMs, virtual machines, whatever it is they need in order to create this application. So this was with VCF, and of course, not everybody had VCF, and there, you know, a lot of requirements here, things around NSXT, especially. Not everybody has NSXT, and so what we did in some of the more recent releases is that we relaxed the requirement on VCF, and in particular on NSXT. There is one drawback of not using NSXT, which is, so if you don't have NSXT, you can use vSphere distributed switches, but the vSphere distributed switches don't provide you with that tunneling mechanism, that overlay mechanism, which means that there was no way to establish secure pod-to-pod communication for the pod VMs. So that's why you don't see the pod VMs in this particular scenario, because there's no NSXT. And also because the Harbor image registry is built on top of pod VMs, you don't have the Harbor image registry service available to you either. So going forward, if you do not have NSXT, the load balancing service is provided. Well, there are a few different options. In the 7.0U1, we provided a HA proxy, and in 7.0U2, we have an NSX advanced load balancer, which is based off of the AVI Vantage product, if you're familiar with AVI or AVI. This was an acquisition that VMware made, not sure how long ago. It's relatively recently, but we've taken that AVI Vantage technology now, and we can use that as a load balancer as well for our vSphere with Kubernetes. So there you go. If you have NSXT, you can absolutely still go ahead and use pod VMs. You can still go ahead and have the Harbor image registry embedded. But if you decide that you're going to use a standalone load balancer and not use NSXT, you can absolutely still go ahead and do vSphere with Tanzu, but you don't have, as I said, all of the services that you would have available with NSXT. So anyway, this is just a breakdown between the three different ones. I don't want to spend a huge amount of time on this. I think I've kind of covered it already. Just the thing to highlight is, again, the different load balancers. First release, NSXT was the only option, but going forward, there are multiple options available. And today, 7.0U2, you could use the NSX Advanced Load Balancer, you could use the HA Proxy Load Balancer, or indeed, if you have NSXT, you can use the NSXT Load Balancer as well. Great, and so vSphere with Tanzu, only available from 7.0 onwards, minimum of 3 nodes, and there's a bunch of other things in here as well. I don't want to spend too much time in them, but there are a number of requirements, but as you go through the wizard for setting this up, all of those are called out for you, and they are checked as well. So I am now going to spend a little bit of time talking about the HA Proxy Load Balancer. This is probably the I suppose the easiest one to get started with, and it's the one that's used predominantly in home labs, proof of concepts, and so on. For production, I guess you could absolutely use it in production, but it's not necessarily what we would see in production. In production, we would either see the NSXT, fully fledged NSXT, or the NSX Advanced Load Balancer, which is now available in U2. But just to get you started, if you were interested in trying this out in the lab or as a proof of concept, the HA Proxy Load Balancer might be the quickest way to get started. So there are two ways of deploying it. If you would just have a look at the green line here, there's a combined workload and front-end load balancer network. And what we mean by that, the workload network is how to communicate, is how the Kubernetes nodes communicate with each other. And then the front-end load balancer network is how we would communicate, or how a developer would communicate with Kubernetes or with the applications. So you could definitely have all of that on one network and segment it up into, you know, two different CIDRs or something like that. But I guess more commonly what we'd see is something like this, where the front-end load balancer network is isolated, well, not isolated, but separated from the workload network, because you see there's a connection between the two of them there. There does have to be a communication between, there has to be the ability to communicate between the front-end load balancing network and the workload network. But just to recap, the workload network would be used by Kubernetes nodes to communicate to each other, but we as administrators, as developers, or as consumers of the applications in Kubernetes connect through the front-end load balancer network. So the HA proxy just comes as an OVA. You just deploy it out. You just fill in all the details. You figure out whether it's a 2-NIC or a 3-NIC configuration that we just described previously, and you know, just fill in all the information. So let me see. Is there a question? Does somebody want to ask a question?
No, I think just someone unmuted himself or herself.
Oh, okay. Yeah. Okay. Thanks, Duncan. If there is a question, feel free to just put it into the Q&A or into the chat, and we can handle it there. Okay, so just continuing on then. The main considerations around deploying the HA proxy are just to do with the networking. There's quite a lot of networking considerations because there's a number of different networks involved when you deploy Kubernetes. And indeed vSphere with Kubernetes as well. So the first of them is basically it's the appliance itself. So you know you have to populate the appliance with IP addresses of its own, fully qualified domain names of its own, and so on. Now, when it comes to vSphere with Tanzu as a whole, there are a number of different networks that we need to think about as well. Obviously, the HA proxy is going to provide us with that list of front-end load balancer network IP addresses. So you have to provide that information as you deploy out the HA proxy. So that all goes into the HA proxy. Once the HA proxy is up and running and everything is working there, and I'll show you ways of checking that, we can move on then to enabling vSphere with Tanzu. We mentioned that vSphere with Tanzu has its own control plane. So there's 3 supervisor nodes or 3 supervisor VMs that are launched as part of that enablement process. You have to give them a range of IP addresses as well. And that looks for 5 IP addresses in total. One of them has to do with the etc daemon, which is the key value store that keeps track of everything in Kubernetes. So that's why there's one additional IP. And then because we can do rolling upgrades of this supervisor cluster, there's an additional 5th IP address that we use during a rolling upgrade so that there's no interruption to the service. Then last but not least, there is the workload network. This is how nodes communicate to each other. So the management nodes, the supervisor nodes, also sit on that workload network to allow communication, and all of the TKG guest cluster Kubernetes that we deploy, they also sit on that network. So there's a range of IP addresses needed for that workload network as well. So yes, you have to do a little bit of work beforehand and get all of that right before you get going. These are 2 tools that I use all the time to verify that the networking is correct. The first one here, the IP address guide. This is just to do conversions between CIDR and ranges, because some places you have to put in the CIDR format, other places you have to put in the IP range. And this just ensures that I get that right. When the HA proxy has been deployed, all of the load balancer IP addresses that we configured it with should be pingable. So I use an IP scanner, the one in here, I call it Angry IP scanner, but there's many more out there. This is just a great way of verifying that the IP addresses that you configured on the load balancer network are actually responding. And if you haven't got this working, there's no point in going ahead with the rest of the vSphere with Tanzu configuration. You have to get the HA proxy working first. So assuming that everything has gone okay, what we should see is something like the HA proxy getting plumbed up on the 3 separate NICs, the management network, the workload network, and also on the front end network. You can stick your Angry IP scanner then onto the front end network, like I said, and hopefully it'll respond to all the IP addresses that you configured it with. There's one final thing you can check, and that's logging in to the HA proxy itself. So you can connect to the URL on port 5556, put in the credentials that you provided during the OVA deployment, and you should get a bunch of information showing at the bottom of the screen there to say, yes, the HA proxy is working as expected. So now that we have the HA proxy working as expected, we can go ahead and enable vSphere with Tanzu in earnest. So let's go through those deployment steps. Like I said, we already set aside IP addresses, network ranges to be used here. So basically what you're going to do is you're going to go onto the vSphere client and now enable what's known as workload management. Like I said, vSphere with Tanzu doesn't show up here anywhere. It's called workload management. And notice now that the networking stack options, you have NSXT or vCenter networking, which is vSphere distributed switches. So we're going to use that one because we're using the HA proxy. So you go through, you fill in all the details. I have a demo coming up shortly. And what should happen is that the supervisor nodes get deployed. Once they're all communicating successfully, it then goes to the HA proxy and retrieves a front-end load balancer IP. And that front-end load balancer IP is now going to be how your developer will connect to vSphere with Tanzu. Great. So what should happen now if we do vSphere with Tanzu enablement is we should see the 3 supervisor nodes, 3 VMs coming up there. They will be plumbed onto the management network and they will be plumbed onto the workload network. So they'll be dual homed, they'll have 2 NICs, they'll be connected to the 2 different networks. And once all that is communicating successfully and they're all validating one another and that they can all communicate, you then get a front-end load balancer IP address where your developer can connect to the supervisor cluster. So let's see a short demo of that taking place. You can see this new workload management section now available in vSphere since 7.0. We are going to use vCenter networking, not NSXT. We do choose a cluster on which we enable vSphere with Tanzu or workload management. I only have one in this case. I'm now going to select the size of the VMs that make up my control plane. Frank spoke to us about this quite a bit. I'm now going to select a policy to use for the storage for the control plane and just use the vSAN default. And now we fill in our first networking information, which is all to do with the load balancer front-end network. And we give it the IP address and port and credentials of the HA proxy. We put in the same range of IP addresses for the load balancer that we put into the HA proxy, and we just put in a security cert there. Now we're on to the management network. This is the management network for the supervisor nodes. Remember, there are 5 IP addresses that need to be provided here. Actually, you only give the first of 5. So it'll be starting from 191 and the next 4 IP addresses after that. And the rest of this is then just basically straightforward networking type information. The last network, the third one, is the workload management network. Now you can create multiple workload networks if you so wish, and you can have different namespaces on different networks, thus different guest clusters on different networks as well. We're just going to create one here. So we're just going to give it a name, select a port group, a gateway, a subnet, And then once again, the range of IP addresses that will be consumed by the Kubernetes nodes on this workload network. Remember, the workload network is how the Kubernetes nodes communicate to each other. The last thing we do is we just add a reference to a content library where all of the images for the Kubernetes nodes are held. And once we have all that populated, we finish the wizard. And that lets us go off and goes configuring. And I can speed things up now, and we should be able to see those supervisor nodes having been deployed out. And you can see the 3 of them there in a resource pool called namespaces. And they should end up, as I said, on both a management network and on a workload network. And at the moment, this one looks good. That has an extra IP, so that looks like where etcd is residing. This one has 2 IP addresses as well, one on each network. And we're still waiting for this one to come up, but it shouldn't take too much longer. So we can speed things up again. And if we just go back and have a look now at the workload management, it is in a config state of running, and it has a control plane IP address that has been given to it on the load balancer network by the HA proxy. So now we can go ahead and we can create our namespace. We just select our cluster, we give it a name, and we select a network. And we only built one network, which is why it's defaulting to it there. And that's the workload network that we just built. And there we are. We were in our namespace. We can offer this to the developer. The developer can download the tools that Frank was talking about to interface directly with the supervisor cluster and build out objects within it, within their own namespace. There's permissions, there's some storage policies that you can allocate as well, so that the developer only has access to those storage policies. We're not going to do anything really on limits. Frank has talked about how to configure those as well, and just make sure that developers don't go crazy in the namespace and consume all your resources. And the Tanzu Kubernetes window there will start to populate as we build Tanzu Kubernetes grid guest clusters, or as the developer builds them. I should be more specific. Okay, so let's look a little bit more at the namespace and the TKG cluster. I think Frank has kind of talked to us about, all the different things you can do in here, but this is basically a way of controlling the resources that a developer has and what they can do within a particular namespace. And it's also a kind of window as well into what your developers are doing. So as I said, the most common use case would be to build these Tanzu Kubernetes guest clusters, and you can actually look in here and see how many of them they have built and what resources they are consuming, and so on. So now that we have this namespace built, your developer can download the tools that we were just talking about. This is one such tool here. It's called kubectl vSphere, and they can actually log into the context of the supervisor cluster and the different namespaces as well. So this is just an example of logging in here. You have to provide a password. I'm going in as administrator at vSphere.local, probably not a very good example. Presumably you would give your developers some other username, which is not so open and a bit more secure. So once they log in, they'll be able to see things like namespaces, and then you can set up what context they can work in, what namespaces they are allowed to use, and so on. So as I said, the main thing that a developer would probably do here is they would build out their own upstream guest Kubernetes cluster to work with, and be able to work with standard container objects, standard persistent volumes, standard Kubernetes services, all of that stuff. And they can build a cluster of their own using a very simple, what's called a YAML manifest. YAML is just short for yet another markup language, but this is an example of a manifest here, which is going to create a guest cluster for them. And a few things just to highlight. We talked about control plane nodes and worker nodes. This is how they will create something like that. Frank talked to us about the different classes. In this case, I'm using guaranteed small. And the very last thing, if you remember in the demonstration, was that we selected a content library, and that content library contains all of the different images, all of the different TKG distributions that we support. And so all you have to do is stick the version number in here at the end, and that will actually pick up that from the content library for you. So there you go. And so they simply just apply this. There's a kubectl command. They apply this. It gets sent up to the supervisor cluster. Supervisor cluster interprets that, and then deploys out the guest cluster on behalf of your developer. Okay, so what will happen then, just to give you a diagram of, we've just created this guest cluster, is that there's one control plane, there's 2 worker nodes. This could be completely different configuration, but in my particular manifest, it's just made up of that. They get put onto the workload network, and then around the control plane, in this case, it's only a single VM, we get the HA proxy providing us with a load balancer IP once again, and the developer again would communicate to that cluster through that load balancer IP address. Okay, so now we have a guest cluster. How does a developer work in the guest cluster? Well, it's a similar command as before, but now we specify a namespace and we specify the name of the guest cluster. Provide a password once again, they're dropped in, and now they're working in the context of this guest cluster rather than the context of the supervisor cluster that we saw previously. So I have one more demo. This is very quickly just building on what we saw previously, and this is just going to show you how we're going to use this namespace to build a guest cluster. So the first thing I do, I'm going to log in. You can see the username and the different the server that we're using here as well. So now we're logged into vSphere with Tanzu, into the workload control plane, essentially. There is a namespace here, Cormac namespace, and that is the context. The asterisk actually represents what the context we're working in. So now we're at the moment working at the supervisor. These are the 3 nodes that make up the supervisor, and we can do various things like look for virtual machines, of which there are none at the moment. The different images, these are all coming from the content library. The different classes, again, Frank has spoken to us about that. You can see where there's a guaranteed small that we used earlier. And here is my manifest to deploy out a new guest TKG cluster. Slightly different to the one that we saw in the slide deck, just to show you that you can change these and use different distributions, different worker counts, all of that kind of stuff. Again, just looking at the classes, you can see there for yourself the CPU and memory usage associated with that particular class. So I'm going to apply this, and as I said, the command is just kubectl apply, and you give it the path to the manifest. And now it's gone off to be created. So this will take a little bit of time, but we can speed things up again. As I said, it's obviously not kicked off yet, but let's take a little bit of time. We can query it in various ways. These are just different ways of querying. You can use cluster or Tanzu Kubernetes cluster, and now it's actually underway in its provisioning. And we can see the control plane coming out first. Again, these are virtual machines. They're virtual machines that are going to run this TKG guest cluster for your developer. So again, we can keep an eye and we can monitor the progress using a describe command to kubectl. Now, these are all the different drivers that will need to be implemented. And again, I can speed things up, and you can see them go from pending to being applied here in this demo as well. So they're all filling in as expected. So it will take a little bit of time for all of the virtual machines in the control plane and the worker nodes to get ready, but they are slowly but surely coming online at this point. So it's almost ready at this stage. And now if we look back in the UI, you can see that we have the worker nodes as well as the control plane, and they're almost all up and running now at this point. If I look at my namespace, I can now start to see resources being consumed. So it's all looking good. Yeah. So one thing I did want to show you now is I want to log out from the context of the supervisor cluster and log into the context of the guest cluster. So I want to now change my context completely into this new cluster that I've just deployed. And how I do that is I provide a few additional options to the command, which includes the namespace and the name of the cluster, because you can have many clusters in the same namespace. Now, when I look at the contexts, you should hopefully see that I'm in the context of the new cluster, the guest TKG cluster. And now when I look at the nodes, I will actually get information about that guest cluster with the one control plane and the 3 worker nodes, whereas previously we were looking at the master. So now your developer, when they're in this context, can actually just do upstream Kubernetes stuff that they might be familiar with already, like pods, services, PVs, PVCs, stateful sets, all of that kind of good stuff. Okay, so I just One last thing to finish on, and this is to talk to you about the vSAN data persistence platform, and it's something that we've just introduced with VCF 4.2, I think just last month. And essentially, you can think of this as having a bunch of different developers working on their own different namespaces, and they want something. For instance, they want an S3 object store on-prem for whatever application they're developing. And so the whole point behind this data persistence platform is that you as a vSphere administrator can instantiate S3 object stores on a per namespace basis. And at the moment, we're supporting Minio. We also have Cloudian, and coming down the line, we have ECS from Dell EMC. So it is a service that you enable on your vSphere with Tanzu deployment. And once that service is enabled, you can instantiate instances of these S3 object stores and give them, provide them on a per namespace basis. The very neat thing here is that if you look at the lower part of this diagram, there's two configurations. There's vSAN and vSAN Direct, meaning that you can provision these on top of vSAN, or if you go with the vSAN Direct approach, you can provision them directly on top of individual native devices as well. So that's a more optimized approach, giving you near native performance off of the devices. But if you're interested in availability and resiliency and being able to do the policy-based storage management that we have with vSAN, you can absolutely do it that way as well. So I'm just conscious of the time. I may have overrun a little bit into my allocated time. So I'm going to leave it there. And please, if there's any questions, I'm going to be around for the remainder of the session while Duncan is giving us an overview of new features of vSAN. So just feel free to ask any questions. So I'll stop the share now. I don't think there were any questions.
There were no questions in the chat, Cormac, but maybe questions will pop up.
Yeah. Okay. I'll let you take it away there, Duncan.
Yeah, thank you, Cormac.
Oh, my pleasure.
Before starting the next session, just I wanted to ask all the attendees to make sure you have registered in the VMUG event website. So we will be doing a raffle at the end of this session, and so all attendees' names should be. So they will be. We will be announcing the winners. 2 of the winners will be getting VMUG Advantage subscription for 1 year. So please make sure that you register in the events page. Thank you.
That is an awesome gift. I wish I could sign up for it. And for those who don't know, the VMUG Advantage subscription actually provides you not only discount on things like VMware exams and courses, but also gives you a whole long list of VMware licenses. So very useful if you have a home lab or you have a lab at work. But that's not what I'm going to talk about. I'm going to talk about vSAN in specific. Cormac primarily discussed cloud native aspect of things from a storage perspective, and Frank already introduced things from a developer / Kubernetes admin point of view. And as I said, my focus is going to be on vSAN and how the vSphere administrator actually leverage vSAN to start building this environment for these cloud native developers or Kubernetes administrators, SREs or DevOps, however you refer to them these days. Now, when we start talking about these new types of technologies, one thing that always comes up is the following, right? They always tend to talk about these traditional or legacy applications, especially when you talk to the DevOps people, and they refer to these the DevOps people refer to these applications as these 3-tiered architectures. Reality is, however, if you look at the current architectures when it comes to implementing these Kubernetes types of solutions, that although there are of course way more layers than 3, if you covered up the layers in terms of the persona using those layers, you will actually end up with 3 distinct layers. As I mentioned, Frank was discussing the Kubernetes side of things, and this is typically what the developer would consume. So the developer actually accesses those Kubernetes clusters and will be able to start creating these containers, and then Kubernetes, of course, will schedule these containers for the developer. Now, of course, then there's the side where Cormac was talking about, and this is the cloud native storage control plane side of things. And this is where you would actually have the ability to provide services for your developers that will allow the developers to create, for instance, persistent volume so that they can store data. And then last but not least, and this, if you look at the diagram, looks like the largest part, but that may not be accurately represented, but it still is a significant chunk of different components for which you as the virtualization administrator would be responsible for. This is not just vSphere, but of course, if you're one of those customers who is planning on providing our cloud native storage capabilities, then typically you will also adopt vSAN. Now, when it comes to vSAN, for those who don't know, vSAN is an enterprise class storage system. And the great thing about the solution is that it has been implemented directly into vSphere itself. So if you understand how the vSphere cluster works, if you can enable HA, if you can enable DRS, you will probably also be able to enable vSAN. It is fairly straightforward. Now, the one thing to explain about vSAN, and this is something that some people don't always fully understand or fully grasp, is the fact that vSAN uses local storage devices. So these are storage devices which are directly inserted into the hosts that are part of the cluster. So here we are talking about SAS disks, SATA disks, or NVMe devices, right? These could be flash or they could be spinning disks as well. When you have these disks available in the system and these disks are part of our vSAN compatibility guide, then you will be able to leverage those disks to create a vSAN shared data store. Now, when you create a vSAN cluster and you start collecting those disks and you will start creating that vSAN data store, one thing that stands out is that you will only have a single vSAN data store typically per cluster. This also means that from an operational perspective, if you compare it to traditional systems, that something actually changes. Because in the majority of traditional systems, what you will see is that you will have one cluster with many different data stores. And then when you need to provision a virtual machine, you will need to select a data store based on the data services that are enabled on the data store. Some of these data services could, for instance, be deduplication and compression, or maybe just compression, or potentially, the data store needs to be configured with RAID 1 instead of RAID 5, or maybe RAID 6, or depending on the type of configuration that you require for the application. Now with vSAN, that works slightly different, because with vSAN, what you're actually going to do is you're going to leverage our policy-based management platform. This storage policy-based management platform is already part of vSphere. So this is not a vSAN feature, it's actually a vSphere feature. Now, the great thing about when you leverage vSAN is that you can leverage SPBM, our storage policy-based management framework. And within policy, you can specify what some of those capabilities for the workloads should be enabled. For instance, you can specify within a policy that a virtual machine needs to be stretched across locations or needs to reside within location. You can specify, for instance, that a application, a disk, a Kubernetes container, a file share, depending on what you're deploying on top of vSAN, needs to be provisioned with a RAID 1 configuration, maybe a RAID 5 configuration or a RAID 6 configuration. So instead of actually selecting a data store when you provision a virtual machine or you create a new disk, you now simply assign a policy to that virtual machine or to that virtual disk. And then when that virtual machine gets provisioned or the disk gets created, vSAN will automatically take care of the data placement. So vSAN will guarantee that we're actually following your guidance as specified within that policy. If the policy states it needs to be a RAID 1 configuration, then vSAN will make sure that at the bottom, you will see two data components, so two copies of the data, and then you will have that third witness component. Now, for those who are not aware of this whole concept, we refer to vSAN as an object-based storage solution. A virtual machine, a virtual disk, a container, a file share, these are all what we are referring to as objects. When you assign a policy and the policy specifies the characteristics of what the deployment should look like, so in this particular example, a RAID 1 mirroring configuration, what you will then see is that you will have two components, full copy full data copies. And then that third component is going to be a witness. Now, this witness only comes really into play when something happens to the network, or maybe a host failure has occurred. That witness is then used as a quorum mechanism. So it's very similar to, for instance, what Microsoft clustering used to use in the past. So very similar to that mechanism. We have that witness component for RAID 1 configurations. For RAID 5 and for RAID 6 configurations, of course, we are here leveraging erasure coding. So for RAID 5, for instance, what you will see is you won't see 2 data copies and a witness, but you will actually end up seeing 3 data blocks and then a parity block. So it is a slightly different implementation. So depending on what you've selected, you may or may not see, a different type of placement in terms of data and different types of objects appearing as well. Now, of course, besides being able to specify within a policy how the data should be provisioned throughout your data center, you can also specify on a cluster level which data services need to be enabled. There are a couple of data services that we've had for a fairly long time. Those data services are deduplication and compression and the vSAN iSCSI target service. They have been around for a while. A bit later, we introduced data at rest encryption. And most recently, we actually introduced vSAN file services in vSAN 7.0. And then we also introduced compression only and data in transit encryption in 7.0 update 1. Now, there are 2 here in this list that actually appear to look a lot like each other, deduplication and compression. And then there's the second one, compression only. And of course, when you want to select one of these options, this is, you need to pick one of these 2. So it's either going to be deduplication and compression, or it's going to be compression only. You can't enable both of these at the same time, of course. Now, the difference between these 2, or one of the reasons that we actually introduced compression only at a later date, we had a couple of customers that requested us if it was possible to introduce compression only, primarily because they were running workloads that didn't deduplicate well. And if you look at deduplication and compression, there is, of course, a cost to deduplicating blocks, and this cost it comes at CPU cycles that are used, and then there's of course some memory that needs to be used as well to deduplicate the blocks. So that is one of the reasons that we actually started offering compression only as well. So when you enable compression only versus deduplication compression, from a performance perspective, a host utilization perspective, compression only typically is the better option to use. Of course, from a disk capacity perspective, so if the focus is on disk capacity, then you will probably want to use deduplication and compression. Now, when we talk about vSAN, there are a couple of things which I also think are interesting. One of those things which I think is very interesting is that, as I've already mentioned, you can specify on a cluster level which data services need to be enabled. You can specify on a policy level what the characteristics of the workload should be. So should it be a RAID 1 configuration, a RAID 5 configuration, or a RAID 6 configuration? However, one of the other things that you can also do with vSAN is you can specify within the user interface what the data center looks like. So if you have one big data center room with multiple racks, and you consider those racks to be a fault domain, so potentially you only have a single top of rack switch, or maybe a single power supply, whatever ends up being per rack, then you can specify within the UI that you have these multiple racks and that each rack should be considered as a fault domain. And then when vSAN provisions the data, and you specify that you would like to be able to tolerate a single failure, it actually takes the failure of a full rack or a full fault domain into consideration. Now, mind you, this doesn't necessarily need to be a rack. If you have multiple data center rooms within the same building, or you have multiple blade chassis within the same data center room, or however you want to create these fault domains, you have the flexibility to create them as you want to create them. Now, we've been talking about vSAN for about 10 minutes now. I think it's probably good to show you what it looks like for those who haven't seen it yet. What I'm going to do in this demo is I am going to show you how you create a vSAN cluster. And at the same time, what I'm also going to do is I'm going to enable vSAN stretch clustering. Now, some of you may have created a stretch cluster at some point in time. For those who have used a stretch cluster configuration with, for instance, Dell EMC or HPE or IBM, whatever it is, know how complex it is, right? It typically takes a week or potentially 2 weeks to create the configuration, to test the configuration, start placing virtual machines, et cetera, et cetera. And when you look at this demo, you will realize that when you use something like vSAN, it is actually extremely easy. Now, I do have to point out one thing here. In this particular case, of course, when I create the cluster, all of the networking configurations have already been done. So I already had the discussion with the networking team. We've already had the network extended between those two locations. So what I'm going to do now is I'm going to create a cluster. I'm going to enable DRS, HA, and vSAN. And then when the cluster is created, the next step is going to be adding hosts to the cluster. Now we've created a new wizard for it. This wizard is called the Quick Start Wizard. It basically allows you to add existing hosts to the cluster or simply select hosts which are already part of your virtual data center. So I'm going to select a host which are already part of the virtual data center and were already added to vCenter server. And then when I select them, they will automatically be added to my vSAN cluster. After they've been added, vSAN will run a couple of checks and it will actually verify that these hosts are correctly configured. And if they are correctly configured, you can now take the next step and start configuring some of the additional data services on your environment. So you're going to click configure. And then what you will see is a new wizard that will provide you the option to, for instance, configure the network. Now, my network is already configured, so I don't need to do that separately, but I do need to create a stretch cluster. So I'm going to select stretch cluster as the deployment type. And then I could, for instance, enable the deduplication and compression if I would like to, but it's all pretty straightforward. Then I need to claim the disks and I will need to determine which hosts belong to which locations. And that's what I'm doing here. So I have 2 hosts in my preferred fault domain and 2 hosts in my secondary fault domain. The next thing I will need to do is I will need to select my witness host. This witness host needs to reside in a 3rd location. And then when I've selected the witness hosts, of course, what is going to happen is that vSAN is going to be configured. It will create a vSAN will create a vSAN logical data store. That logical data store is stretched across those 2 locations. And then, of course, that witness host, which resides in the 3rd location, is connected to the cluster as well. In case anything happens to the network in between those 2 buildings, that witness host will allow vSAN to determine what has happened and who owns the data at this particular point in time. So that witness host only comes into play when there's a failure scenario. And basically that's all that we had to do to create a vSAN stretch cluster. So as I've already mentioned, you create this vSAN stretch cluster, you will get 2 fault domains. In this particular case, 2 fault domains with 2 hosts each. And of course, there's a witness host assigned to this stretch cluster as well. Literally, although I, of course, had to speed up certain parts of the video because we don't want to watch disks being formatted for 10 minutes. But if you click through it, in roughly the same pace as I did, you will probably be able to configure a stretch cluster configuration using vSAN within 15 minutes or less. So that was the configuration part of vSAN. And of course, besides being able to configure it, besides being able to deploy virtual machines on top of it, one of the other things which I think is where hyperconverged infrastructure excels is how you scale or how you grow the environment. And I think this is one of those unique things, right? If you have a traditional storage system, typically what you will end up doing is you will make a prediction in terms of the amount of storage that you will need in the upcoming 3 years. You will then buy, a huge storage system, and you will have, potentially 50, 60% of the resources sitting there being unused for a significant amount of time. With HCI, that is slightly different because with HCI, you can actually grow the vSAN data store by adding additional hosts to the cluster, by adding additional disks or disk groups to the hosts that are already part of the cluster. So you can introduce new storage resources in the cluster as well. Now, that has led to, some interesting situations with customers because some of the customers said, well, we've already have 20 different vSAN clusters and some clusters have, still 50% capacity available and others, may have only 5% capacity available. So is it possible to actually share vSAN storage between those clusters? Now, this never used to be possible, but this is something that we've actually changed starting with vSAN 7.0 Update 1. With vSAN 7.0 Update 1, we've now introduced a new feature called HCI Mesh, and HCI Mesh now provides the administrator to the ability to start mounting vSAN data stores when your cluster that you're doing this task from also has vSAN enabled. So you mount a vSAN data store, you create a new virtual machine, and you can actually place that virtual machine on that remote data store. So not your local data store, but your remote data store. This then also provides you the ability to start vMotioning virtual machines from one location to the other location, or one cluster to the other cluster, I should probably say, and without actually moving the storage, which is something that you would normally need to do with vSAN. But when you have HCI Mesh available, of course, you can have the storage being hosted in another location. One of the other added benefits that this adds is if you have, let's say, 4 clusters, 2 of those clusters are hybrid clusters, so you're using flash plus spinning disks, and the other 2 clusters are using all flash. Using HCI Mesh, you can now start provisioning virtual machines from a compute perspective on your hybrid cluster, while from a storage perspective, these virtual machines are actually located on your all-flash cluster. So it opens up a lot of possibilities. Now with vSAN 7.0 Update 2, what we've actually introduced on top of that is the ability to share vSAN storage with vSphere or compute-only clusters. So even if your cluster isn't running vSAN, you can now also leverage HCI Mesh to expose vSAN storage to it. So this provides a lot of additional flexibility. And the great thing about it is that those compute clusters don't need to have vSAN licensed. So it comes at no additional licensing cost for that vSphere or that compute-only cluster. Now, I want to show you what that looks like, because I think it immediately shows the power of HCI Mesh. In this case, on my cluster, I already have vSAN enabled. I'm going to show you that I have vSAN up and running on my vSAN cluster. And then what I'm going to do is I'm going to go to my compute cluster. In my compute cluster, I don't have any local storage at this point in time. So what I'm going to do in order to be able to provision virtual machines is I'm going to say, click configure vSAN, and then I'm going to select vSAN HCI Mesh compute cluster. So it won't have any local storage, but it will have the remote storage available that is available on the vSAN cluster. So after it has been configured, so we're now loading the vSAN client on those 2 hosts in my compute cluster, I can simply mount the data store that belongs to the vSAN cluster. So I'll select Mount Remote Data Store. And then after I've clicked that, I can select the data store that I would like to mount. I can, in this case, mount 1 data store, but if I have multiple data stores, I could even mount 2 or 3 different vSAN data stores to this compute cluster if I desire to do so. So you have that flexibility available as well. When you're mounting it, it will actually do a couple of checks to see if the environment is correctly configured. And if that has been validated, you can click next, and then the data store is going to be mounted. After the data store has been mounted, you can start creating virtual machines. So now when I create a virtual machine, I can select the data store of that vSAN cluster. So this is that remote cluster that I'm using. I can also select, different storage policies, RAID 1 or maybe RAID 5, of course, depending on what the capabilities are of that vSAN cluster. All of those options are available with HCI Mesh as well. The other thing that I want to point out is that as soon as you have provisioned a cluster or have provisioned a virtual machine, and from a monitoring or operational perspective, you want to look at the cluster, of course, you can, or on that virtual machine, sorry, you can click on the virtual machine. And then when you click on the virtual machine and you go to monitoring, within the monitoring section, when you look at physical disk placement, it actually shows you where it's being stored. Now, the other thing that we've introduced in 7.0 Update 2 is some additions from a storage policy perspective, because you now have the ability to start cross-connecting all of these different vSAN clusters. Let me pause it briefly here. You can also imagine that some of these clusters may have deduplication and compression enabled. Some clusters may only have compression enabled. Some may be hybrid. Some may be all flash. Some may have encryption enabled. In that particular situation, you can specify within a policy which data services need to be enabled for your particular virtual machine that you're deploying. So if, for instance, from a compliance and regulations perspective, there is a hard requirement for a virtual machine to always be encrypted in terms of data at rest, you can simply select that within the policy. And now when you provision the virtual machine and you select the policy, only the data stored that have encryption enabled will be shown to you. So this is also something that was introduced in vSAN 7.0 update 2. Now, of course, when you select these different combinations, you need to make sure that all of the combinations are correct. In this case, I've selected compression only. So that is only possible when you have an all flash configuration. So also from a storage tier perspective, would need to select all flash. And then, of course, when I provision my virtual machines, I can simply select the policy that we've just created, and then the data stores that adhere to that policy when I provision the virtual machine are going to be available as a location for my storage. Now, there are a couple of considerations here. I'm not going to read these considerations out loud one by one. I actually have a blog post available on yellow-bricks.com. If you do a search on yellow-bricks.com for considerations, you will see the considerations that I have for HCI mesh, but also for vSAN file services. There are two that I want to point out here. First of all, a client cluster can only mount a maximum of 5 remote data stores. So that is the limit that you can have. So that mesh that you can create can only be 5 by 5 at most. And the other thing that I want to point out is that you cannot exceed a total number of 122 hosts connected to the same data store. So that is also a limitation that you have. So if you have, 5 clusters each with 32 hosts, then of course you will exceed this limit. So that is something you need to take into consideration for HCI mesh specifically. Now, I've already mentioned vSAN file services a couple of times, and I know Cormac already mentioned it as well. So let's talk about vSAN file services. For those who aren't aware, we introduced vSAN file services in 7.0. With 7.0, we actually introduced support for NFS version 4.1 and version 3. In 7.0 update 1, we also introduced support for SMB version 2.1 and version 3. And on top of that, we've also introduced support for authentication through Kerberos for NFS, and then Active Directory for SMB specifically. Now, when we initially introduced this, our primarily targeted use case was containers, but now that we also have support for SMB, I think it's also suitable for other types of use cases, for instance, user directories, or you could use it for traditional workloads that require an SMB share if you're using Windows virtual machines, etc., etc. Now, of course, we also made a couple of enhancements with 7.0 update 2. And one of those enhancements is that we now also support a stretch clustering configuration with vSAN file services. So if you have a stretch cluster configuration and you would like to enable vSAN file services, this is now also something that we support. I actually have a demo, so I will show you what that looks like in a second. The other thing that we introduced in 7.0 update 2 is support for snapshots for vSAN file services specifically. This capability is available through the UI and is primarily targeted at our backup vendor partners. So it allows backup vendors to be a bit smarter around how they can actually back up vSAN file services. Now, of course, this is still relatively new, and there's a whole bunch of vendors out there that already provide, guidance around how to back up vSAN file services to begin with. Veeam is one of them. They have a whole reference architecture detailing how you can back up this solution. But hopefully in the future, they will also be on board with this snapshotting mechanism, and it will even make the solution they have available today more efficient. Now, when it comes to the implementation, I just want to briefly step through this because it has been implemented in a slightly different way than the vSAN implementation has looked like so far. If you look at NFS or SMB as an example, and you connect from an NFS client to an NFS server, of course, that NFS server needs to run somewhere. Now, in our case, that NFS server runs on top of vSphere, so it runs on top of ESXi, and you will not have a single NFS server or SMB server, but you will actually have multiple of them. Of course, depending on the number of nodes, you will have an X number of NFS or SMB servers. Now, The interesting part here is the following. The NFS server or the SMB server is actually implemented as a container technology within a virtual machine for now. You can imagine that over time, this container technology will actually start running natively on top of vSphere. But for now, it has been implemented as a virtual machine. For each host that you have in your cluster, you will normally see one of those virtual machines being provisioned. And then within each of those virtual machines, a protocol stack container is initiated. And within that container, of course, you will have those NFS services and SMB services running. vSphere is completely responsible for deploying those virtual machines and instantiating those containers. So you as an administrator don't need to do anything about that. We use the ESX agent manager that actually deploys these services for us automatically. Now, when you create a file share, however, one of the things, of course, that you're going to do when you create a file share is that you're going to associate a policy with it. As soon as you associate a policy with a file share, what is going to happen is that vSAN is going to take over, and vSAN is going to create multiple copies of that data based on what was specified in that file share. If it's a stretched cluster configuration, it will ensure that the data is stretched across locations, for instance. So we have that capability available as well. And then, of course, all of those objects will be formatted with a virtual distributed file system, and that file system will then be exposed as SMB or NFS to that NFS client. Okay, let me show you what it looks like. I think it's an interesting solution, and of course, it has been implemented in the H5 UI. I've already have a vSAN cluster enabled. I've also already enabled or created a stretched cluster configuration. And what I'm going to do now is, on top of this stretched cluster configuration, I am going to enable vSAN file services. With vSAN file services, what I'm going to do is I'm going to make sure that vSAN file services is aware of the fact that this is a stretched cluster configuration, so that from a latency perspective, when you connect to vSAN file services, you can actually take the location into account as well. So the first thing I will need to do is I need to specify a file service domain name. This is an internal construct. And then, of course, I will need to specify the DNS server details and the DNS suffix. I could integrate it with Active Directory if I want to. I just want to create provide you a basic overview, so I'm not going to do that for now. But what I will need to do is I will need to select a network to which those file service containers are going to be connected. Now, besides selecting the port group, I will need to specify the subnet mask and the gateway, and then I'm going to specify the IP addresses. After I've specified all of the IP addresses, what I will need to do next is I will need to click on lookup DNS. Then all of the DNS names will be resolved and automatically added to the UI. And the next thing that I will need to do is I will need to specify affinity for each of these IP addresses. Now, this is where the stretched clustering aspect comes into play. Affinity actually refers to the location. So if I would go back a couple of seconds, you may recall that we had these two fault domains. The fault domains were called preferred and secondary, and these are the same. These are listed the same here, preferred and secondary. So for each IP address, I can specify to which location they have affinity, which will then allow me, when I connect from a virtual machine to an NFS or an SMB share, to specify through which site I would like to connect. This basically prevents that virtual machine from hopping across the intersite connection to the other location to, for instance, do some type of I/O. So it provides a low latency, the lowest latency path available for that virtual machine or for that application. That is why we introduced this capability. Now, after we've enabled vSAN file services, as I said, what's going to happen is agent virtual machines are going to be created. Within those virtual machines, the containers will be created for those file shares, which will then allow me to start creating file shares. So I can now provide a name for the file share. I can then select the protocol. And then what I can do is I can select a policy. In this case, I'm going to ensure that the data is stretched across locations. And then the next thing that I can do is I can specify with which site we would like to have affinity. So I'm going to select preferred. I'm going to set a warning threshold and a hard quota for this particular share as well. And then I'm going to click next, finish, and that share is going to be provisioned. Now, when the share is created, I can then provide the details to my user, and when he connects to the share and his virtual machine resides in the same location as the share resides, you can imagine that the I/O from a read perspective and from an access point of view is going to be local. When I look at physical disk placement, I still see multiple RAID 1 configurations, and this is because I've selected the stretch clustering policy. So although we will access it locally to the site, the data is still replicated between two locations. So it does provide me the stretch clustering availability. Now, the last thing that I want to discuss is how you can manage and operate an environment when it comes to vSAN. And one thing that I want to discuss, briefly is everything around analyzing I/O metrics. And this is one of those things that customers have been challenged with for a while. And you may have experienced this with vSAN or maybe with vSphere as well the past couple of years. One of those questions that always arises when you start creating a design or you start deploying new applications is, what kind of I/O is the application doing? And this is always difficult to answer. If you ask, a database administrator, you probably won't get, the correct answer. Now, this is one of the reasons we created a tool called I/O Insight, and I/O Insight was released as a fling a while back. But what we've actually done recently is we've introduced I/O Insight as a solution within vSphere itself. So starting with vSAN 7.0 Update 1, you now have the ability to analyze virtual machines from an I/O perspective. Let me just show you what that looks like, because I think that is probably the most interesting aspect. When I right-click my cluster or when I right-click a virtual machine, I have an option called vSAN. Under that vSAN option, I have the option to select a new I/O Insight instance. And when I select that, I can select the virtual machines that I want to trace from an I/O perspective. I will select my vCenter server virtual machine. And then when I click next, I can select for how long I want to trace this virtual machine. I'm just going to select 10 minutes. And then after the 10 minutes have elapsed, I will show you the outcome of the trace. So the trace is now starting on the host. That virtual machine is going to be traced from an I/O perspective. And if I go to the monitoring section of the cluster itself, and I go to my vSAN section, I can see that there's a new option called I/O Insight. When I click I/O Insight, I can see the instances that are either done running or are still running. In this case, it's still running for about 9 minutes. So we'll speed up the video, and then in a couple of seconds, it should be done, and we should be able to actually look at the data. Of course, besides looking at the data, if I want to delete this instance, if I no longer need the data, I can simply click on the 3 dots and then delete the instance, rename the instance, or I could even do a rerun. In this case, I'm just going to look at the instance, and it will then instantly show me all of the details in terms of the I/O that has been doing. So the number of IOPS, the throughput, whether the I/O is sequential or random, what the ratio is between sequential or random, if the blocks are 4K aligned, what the read-write ratio is, what the I/O size distribution is, and even the latency distribution. So, all of the information that you could wish for is available with I/O Insight, starting with vSAN 7.0 Update 1. It's not, of course, available for a single disk. It's available for all of the different disks that are part of your virtual machine, or the multiple virtual machines that you are tracing at the same time. Now, what we're going to do in the future is we're actually going to take it one step further. And I think this is something that you may find very interesting. At least I think it's very interesting. And it's going to be very useful for customers. Is we're planning on introducing a new feature called I/O Trip Analyzer, or at least this is the engineering name that we've been using for it so far. And the I/O Trip Analyzer basically is going to be very similar to what we've just seen with I/O Insight. It will provide you that one-click analysis. It will then provide you all of the details in terms of the I/O, but it's also on top of that going to provide you a diagram that will show you all the way from the virtual disk down to the physical capacity tier, what the latency is that is introduced on every single layer, right? In this particular case, vSAN is a distributed storage system. So what is going to happen is that it's probably going to hit the network. Then when it has traveled over the network and it reaches a host, of course, it's going to hit a NIC again. From that network card, it's probably going to hit a disk controller then it will hit the caching tier and it's going to hit the capacity tier. And all of those different layers, latency may be introduced. In the future, the IO trip analyzer will actually show you what the latency is that is introduced for all of these different layers. So hopefully that is something that you will find is interesting and is something that you may be able to use in the future. With that, we've reached the end of my part of the session. So if there are no questions for me to answer, and maybe Cormac or Frank can speak up if there are any questions, because I didn't monitor the chat or the Q&A window. But no, if there are no questions, okay, great. Then I will hand it back to the VMUG team, and then the VMUG team can start handing out that VMUG Advantage package. Let me stop sharing and hand it back to you guys.
Thank you, Duncan, for your excellent presentation. I guess I know it's we are back from holiday, so we are in like beginning of a new session. So anyhow, we are missing the physical presentation which we used to have physical sessions before the pandemic, and now we are into the virtual sessions. So especially we are missing the physical meetings and the dinner. So now we will be doing a raffle for the VMUG Advantage. Just let me share my screen. So basically, for the VMUG Advantage, there is two types of membership. One is general membership, and another is the Advantage membership. So in the Advantage membership, you get all the benefits of user conferences, virtual. You will get notifications for the virtual events and local community meetings, and you will have access to online communities. And in the Advantage, you will have like 20 to 30% of training discounts, and you will have the evaluation licenses for the whole year, and you will be having a exclusive VMworld discount if it is if this year it is going to be. We are not sure if it is going to be a live physical event or it will be a virtual event, but so these are the advantages which you will get. Like VMUG is a community driven, and we share the knowledge between the VMUG members. So this is general information about the VMUG Advantage. Okay. Now I will be. We have around 20. I think we have 20 attendees. Right. So let's make a raffle for all the attendees. Yeah. Shall I start, Abdulaziz?
Yes, please go ahead.
Okay. Bismillah. This is for the first winner. So, can I see? Can you raise your hand, Ray? Are you present? Yeah. Okay, Ray. We will send you a notification by email, and you will be sent all the details for how to register for the VMUG Advantage, and we will give you the send you the email. Please share your email address. We have already your email ID, so we will try to send you the details. Thank you. And now we will go for the next raffle. Congratulations, Abdul Muqid. Can you raise your hand? Yeah, excellent. Yeah, thank you, Abdul Muqid. So congratulations for both the winners, and thank you for your time and participating in the event. So whoever is the winner, we will send you the details about the VMUG Advantage subscription. And thanks for all the participants and all the panelists who has given the time for the excellent presentations. And I also thank Abdul Aziz for initiating this event and for all his follow-ups. I hand over to Abdul Aziz if he have to say something.
Thank you, Sadiq, and congratulations for the winners for the VMUG Advantage. I hope you enjoy this. I hope you enjoy this surprise and giveaway. And I really would like to take this opportunity to thank Duncan and Cormac and Frank for this fruitful session, and it's very informative, and it was very a good opportunity. And we are looking to plan similar sessions in the future for VMUG Saudi Arabia. Thank you so much, really, for your time.
Thanks, everyone.
Pleasure. Yeah. Bye-bye.
Bye-bye.
Bye-bye.